This is Tim Hegarty with the virtual training company C++ Fundamentals. We are going to look at exception handling now. Modular programming has caused error handling to have to be split into two distinct operations. We now have multiple functions and classes and libraries running around out there that are detecting errors, but they don't know what to do about it. They have to give those errors over to some other local code, which our new user is writing, our new developer is writing, so that they can deal with the error and report it or resolve it in some way. So the reporting of errors has to be taken care of, and the handling of those errors has to be taken care of. Two different sections, reporting and handling. We're going to do that with a new construct called the try, throw, catch. It's really pretty simple once you see an example of it. Try is a statement block. You see the braces there, an open and close brace, and it will have a bunch of C++ code inside it. That's the code that we're going to try to perform and see if we can do it without having any problems. If we hit a problem someplace inside the try, we will throw an exception, and an exception is just a type. It's a class or an integer or a character or something like that. It's just a type. That is used within the trying code to report that an exception has occurred, and now somebody has to deal with it. The catch statement block is written directly after the try statement block, and the catch block will contain the error handling code that can actually do something about the error. It just depends on what the error is. So let's take a look at a little piece of code that I've put together for us here so that we can prove this out. First, you have to include exception. So that gets your exception handling in place. So we do a pound include exception. I've included IOStream just so we can talk to the outside world, and then we use namespace standard. Now here is a new type. This is a struct called demo error. Doesn't have anything in it, obviously. It's empty, but that does create a new type, and we can pass that thing around. You can do a throw of an int or a character, but that's kind of ambiguous and doesn't really explain anything. Here you can have a lot of different errors, and you can even have information in them so that you can throw information about the error, maybe a file name or an operation you were trying to perform, something like that. It's completely up to you how much information you throw when you do throw it. Now here down inside our program main, we have our try block. This is everything that we're going to try to accomplish and maybe have to throw an error. Right now there's a comment. We'll use that in a minute. Here we set up a long for 100. Here we set a myArray of integer pointers, and we're going to set them equal to a bunch of new integers, a number of them. And in this case right now it'll just be 100. Eventually we'll try to make 1 billion of them, and I guarantee you that won't work. Here we do a bunch of other work, whatever's going on in our try block in our program, and then just for grins we will throw the demo error. So this is how we throw a demo error, which is this thing up here, this structure. So we're going to throw this type, and then here's another line that's after the throw. Well, that's strictly there so that I can show you that we will never get there. When you throw out of a try block, the try block is done. Nothing else is going to get executed within this try block. Now here's our catch blocks. The catch blocks have to be directly after the try block. They have to be the next set of statements after the try block. And we can have a bunch of catches. We can catch all kinds of things coming out of the try block. In our case, we're going to catch our demo error, which is that structure, and we're going to say, I caught the demo error. Obviously, you'd do something important with the error that you caught. Here, I just want to show you we got it. If we don't catch that one, there might be another one we can catch. This is our standard exception reference. So here we're going to catch a standard exception coming from the operating system. In this case, this will catch our memory allocation problem. And there is a method called what, which is a way of finding out what particular standard exception did we hit. So e.what will give us that exception. And here's an everything else. Catch with an ellipsis in it are all the other throws that might come through, and we don't have them specifically noted. Don't have to do that, but it's a good thing to have there so that you can catch other exceptions and maybe do something, maybe recover before bailing out of the program. We'll say something else happened. Down here is the last line of our conventional program. This is the bottom of main down here. So we have our catch, and this is our last line that we're leaving the program. So let's see what's going to happen. We should only get our demo error thrown. So let's run this. And there it goes. I caught the demo error and now leaving the program. He did no other work in that try block after throwing that demo error and catching it. Now let's give him something else to think about. We'll take out our comment here and we'll put it in down there, so that now we're going to ask for way too many integers than we have memory for, and let's see how that works. Standard exception, bad allocation. And again, right after the catch block, we're now leaving the program and press any key to get back here. So that means that we never got to this demo error. As it was trying to allocate too much memory, it failed right here and threw an exception. And since we were in a try block, it understood to start working through the catch blocks, and it found this one. This was the standard exception that was thrown out, and that's what told us our exception. Now that's try, throw, and catch in exception handling. Now imagine in this try block, what if we had made a function call, which called another function, and so on, and we were down deep in the program? Well, stay tuned. We're going to show you how that is handled. Hi, this is Tim Hegarty with Virtual Training Company, C++ Fundamentals. We're talking about exception handling, and you've seen try, throw, catch, and that sort of thing already in our previous video. Well, now we want to talk just for a minute about exception specifications. An exception spec limits the exceptions that any function may throw while it's running. If there is no exception spec off of the end of a function definition, then that means that it can throw any exception. There's no limit. An empty exception specification means that this function is not allowed to throw any exceptions at all. So there you see a void of my function with an empty throw, throw with nothing in the parentheses. So this my function would not be allowed to throw any errors, and that lets the compiler not try to ever produce a catch or a jump to a catch or anything like that, because it knows that this thing will not be calling on any exception handling to be performed. The next one there, the void my function with throw my error, that could be an integer, a character, any type. How you saw we did that before. That means that my function would only be allowed to throw my error, and the compiler would be smart enough to understand what to do about that and how to set things up. Now here's the tricky part. This is not supported by Visual Studio C++, the .NET. So Microsoft currently, in their current edition, does not support exception specifications. So just so you're aware, don't try this at home, because it won't work unless you are using a different compiler. Okay, the Microsoft that we have been using so far does not support this. So anyway, I want you to know that it's there, though. That's an exception specification as part of exception handling. Hi, this is Tim Hegarty with the Virtual Training Company and C++ Fundamentals. We're finishing up our talk here on exception handling with the concept of stack unwinding. Remember, I asked you what would happen if you were in a try block and a try block made a function call, and maybe that function that it gets called into creates some class objects, and their constructors get called, and then we do some other work and call another function, and then we throw down in the middle. Well, that throw is going to cause us to have to undo all of the work that has occurred before the throw. We have to go through all of the destructors for all of the objects that were created in reverse order, just the way we do when we're exiting the program. So we have to release all that memory, run all those destructors, and then find our way to the catch blocks and see if we can get a catch block that will fit our throw. If there is not a catch block to fit, we will call a function called unexpected. Unexpected simply does an abort, which dumps off the rest of the code and exit out of the rest of the program. There is also a terminate. There's a terminate function that can be called if we try to catch an exception that we have not taken care of. We have not set up a catch for the particular kind of exception, so we can go and do a terminate. So let me show you some code here. Code's always simpler to talk about. So here we have this is a new structure, and it has a message in it, and it has a constructor that will build this message. So E can be used with a message in it, and that's what we're going to be throwing is our error structure. Now here's a new function called myTerminate. We want to replace the terminate function that's in as part of the runtime so that we can see something happen. And we will replace that with a little output called a myTerminate that were there. Here's a simple structure A with a constructor and a destructor, and here's a structure B with a constructor and a destructor. Now notice here the destructor of A, while it's saying I'm here in destructor of A, it then throws another exception. So we get another exception while we are trying to get out of the original throw. That will cause the terminate to run. Alright, so that's an exception thrown in the destructor. Now we're going to see some very odd behavior, which you've certainly seen from programs before, but now you're going to know a little bit of what goes on. Here's our main function, and we have try, and we're going to call setTerminate. SetTerminate tells the runtime to use this function, myTerminate, as its termination function, so that should the runtime have to call myTerminate, or has to call the built-in terminate, it will in fact call myTerminate. So we set that up first. Then we say that we're in our try block, and we build A and B of our structs. It's really just classes A and B, and then we will throw an exception. So an exception is thrown in the try block of main, and that's our pointer. That's a character pointer, so that's going to match. Now, when that throw occurs, we have to undo B, and then we have to undo A. We have to destruct them. So we will go up into the destructor of B, and then, because it's in reverse order, then we'll go into the destructor of A, and we will throw another exception. And that's when everything's going to break loose. And you're going to see what happens. We're going to call the myTerminate, but also Windows is not going to like it. Here's our catches. We can catch our constant character pointer, and that is our normal exception handler. Here is everything else, some other exception, and here is resuming execution of main after the catch blocks. So let's run this and see what happens. See, we were in the try block, and we got into the constructor of A, we got into the constructor of B, then we were supposed to undo everything. We did a throw. So we had to hit the destructor of B, and then we got into the destructor of A, and at that point we did another throw, and that second throw did a call to myTerminate. Well, myTerminate worked, but it also calls into the operating system and tells it that we have requested to terminate in an unusual way. Windows does not let this go easily. So we can ignore this termination, and we will still get our little press any key to continue. So this information comes on through that the application has requested to terminate in an unusual way. All right, that's the kind of thing that happens. You can set your own termination, but you have to be very aware in stack unwinding of the terminate function and the unexpected. The unexpected function is done the same way. Set unexpected and then some function name if you don't want the compiler's unexpected to be called. And unexpected, again, is only used if you don't have a catch like this with the ellipsis, because that's catch everything, and of course unexpected would not be called because you expected everything by including this. If you didn't use this catch with the ellipsis in it, and you only had specific catches, if you if you threw something unexpected, there you go. You're going to call the unexpected function. And in the normal C++ runtime, unexpected just aborts the program. It throws away everything else and closes up shop and leaves. That means files are hanging open and whatever else was going on. So it's not a clean way out. You want to at least try to have this catch ellipsis if you're going to be using try, catch, and throw blocks. You want to have this one so that you can try to catch everything else and not wind up into that weird condition we had with the unexpected. And also in the termination. And remember, you get to terminate if a destructor does a throw, if it has a problem while it's destructing. It's entirely possible, but you want to try to code your way around so that you do not try to throw an exception while you're getting out of an exception.